So first we cut the cabbage and then blend it with deionized water, as this will not affect the pH. This ensures that the pigment anthocyanin is released. Then we strain the solution so we get a watery consistency. Then what we're going to do is prepare the test solutions, as you'll see in the next clip.
Hi everyone, my name is Bailey and today we're going to be doing an experiment testing cabbage as a pH indicator. So the first thing that we're going to do is put our hair up because lab safety is important. Make sure your hair doesn't get into anything. And also safety goggles, because some of these compounds are not good for your eyes. They can irritate your eyes. So I have several compounds that you can just find around the house. Here we have citric acid, which is also lemon juice, acetic acid, which is vinegar, rubbing alcohol, which is also known as isopropanol, and this is distilled water, baking soda dissolved in some water, also called sodium bicarbonate, and this is going to be bleach, and that's sodium hypochlorite. And here we have just our cabbage in water mixture. So the first thing we're going to do is our citric acid, and this is very acidic, so it should turn a pinkish reddish color. So let's test it. So as you can see, it turns a pinkish color, so it is indeed acidic. And then here we have our acetic acid. And this one also turns pink, so that's also acidic. Then we have rubbing alcohol. This one is fairly neutral because it looks similar to our cabbage mixture. And then this is our control. This is our distilled water. You see no change in the color there. Here we have our baking soda. This is going to be on the basic side, so it's going to turn a bluish color. And as you can see, it did turn blue, so it is basic. And so then here we have our bleach. This is going to be very basic. Well, that's my prediction. So let's see what happens. So at first you don't see a color change, but so now you can see that it's yellow. We completely passed the green pH because bleach is extremely basic. This is probably around a pH of 13 or 14. And there you have it. These are our compounds that I tested with our pH indicator. Hello class, and welcome to Chemistry with Bailey. So today we're going to be talking about pH indicators, specifically purple cabbage. The reason that red cabbage works as a pH indicator is because it contains a natural pigment called anthocyanin. This purple structure, is what the pigment anthocyanin looks like when it is in acid. See here are citric acid and acetic acid. So this is what it's going to look like, and as you can see, it is protonated, in protonated form, and also it's very conjugated. The conjugation allows it to reflect in the visible light spectrum. There are several hydroxyl groups that make it water soluble. And with a low pH in the acidic form that's protonated, it's going to show up as a reddish pink color. And then over here we have what anthocyanin looks like in base. As you can see, it's deprotonated and its conjugation is a bit different. However, still has these hydroxyl groups that make it water soluble, but As we saw in the baking soda and bleach solutions, we saw that they were more in the blue and yellow visible light spectrum. So as you can see, since this is the acidic form of the molecule and this is the basic form of the molecule, the pH of the solution that our red cabbage is in affects the conjugation of the molecules. And visible light is absorbed due to the conjugated bonds in the molecule. This affects the wavelength of light that we see as the different colors in the solution.